The next method that we're going to introduce is FP-Growth. It's a frequent pattern growth approach. The idea is to use a clever data structure to hold all the information that the transaction database holds, so that everything, the mining part, will be done in memory over this FP-Growth tree. So we don't have to go back to the database and scan the database for the counts. So the FP-Growth method was developed to address the bottlenecks of the a priori approach, which we have discussed earlier. Huge number of candidates and large of database scanning to find the counts is costly. So FP-Growth approach is about 10 times or more faster than a priori, depends on how dense the dataset is. It took a divide and conquer approach. It does not need to count the candidates support. It has the data attached to this data structure. So the intuition behind FP-Growth method is to grow long patterns from short ones using local frequent items only. So local. What does local mean? Local means a partition. Not the entire database, but only the part of the transactions that's relevant for a subset of tasks. So for example, if ABC is a frequent item set, then let's get all the transactions have ABC. Okay. In other words, we project the entire database onto ABC and find a subset of this local partition of the transactions that containing ABC. And then within this local context, we find frequent items and see whether we can grow this pattern or not. Okay, so this is the intuition. We're going to run one example through the algorithm to get some intuition, and then we will summarize this by verbally describe what this algorithm is. So we have, let's see, we have a transaction database. Let's make it a little bit clearer. Okay. So we have a set of 5 transactions. The items bought are listed here. The first thing we do when we perform FP-Growth algorithm is to start to build the FP tree. This is a FP tree. So first we need to scan the database once, find the frequent one item set. This is exactly the same as a priori first step. We need to scan to find the frequent item sets. So the information is presented here, the item sets and their frequency. We have a minimum support of 3. So some of the items, for example, L, that does not meet the minimum support are dropped. So here, after we get the frequent one item set, we start to construct the ordered frequent item set. So we sort frequent items in frequency descending order. So this gives us the F list. F list, because F occurs most often, and since C, if there is a tie, the tiebreaker is arbitrary. Okay, you can use whichever. But once you have the header table, the order decided in the header table, you will just use this table as a fixed order. So FCMB, FCABMP is the order, the frequency order. Therefore, we sort those items, list the most frequent item first. So this transaction becomes this. Single items that does not meet the minimum support are dropped because they will never show up in any frequent patterns. So with this, we start to scan the DB the second time. So FP-Growth algorithm only need to scan the DB second time. After scanning the DB the second time, we would have created this header table and the entire FP tree. And we have all the information from the database encoded in the tree. So we no longer need the database anymore. All the subsequent computation are done in memory on the tree. So let's see, how do we construct this tree? So we will do this. We'll use the ordered frequent item set to construct the tree. So we first, initially the tree has empty root, stays here. Then we first read this transaction FCAMP. So we put F here, grow a branch, put F here, and then from F we grow another child node and put C here, and grow another child node from C to put A here, and M and P, right? So initially when we put the first transaction into this tree, every item have a count of 1. Okay, and those count will start to be adjusted when we read more transaction records. So now the second transaction records we're going to read in is FCAMB. So now the tree has this branch already, and each item has a 1, count of 1. Now with this F read into this, we see, oh, there is the F. We already have an F. Let's just increase the count. The count becomes 2 at this point. And after F, we have C. Oh, we already have C. Okay, let's increase the count of C. Similarly for A. But when we read to this B, we see, oops, A has a branch of M, but it doesn't have B. Okay, we have to grow a branch of B and put the count 1 here. And the following B, we have M with count 1. Okay, so second record was reading. And we read the third one, FB. Okay, F goes here, and B have to create a new branch, CBP. So from the root, we have F branch, but we don't have a C branch yet. So let's create a C branch. So CBP, okay? And FCAMP goes FCAMP. So increase the count when we have a new item touch one of the relevant node. While we're doing this, we started also at the same time to add the links to our header table. So so all the nodes containing F are linked through a linked list. So F is linked to this F, and we don't have other F in this tree, so that's the end of this link. For C, we have this C, but we also have another C on this branch. So we will have a link from this header table to the first C node, and from the first C node to the second C node. So every C's are linked through this linked list structure. So this, the header table plus the tree forms the entire FP growth tree. Okay, the future mining going to be conducted here. As I put it in under highlight that our FP tree contains all the information in the DB. Therefore, we don't go back to DB for any scanning. Then we have this DB tree, this FP tree there. How are we going to perform frequent item set mining? The idea is to recognize that the entire set of frequent item set can be partitioned into subsets according to the F list in reversed order. So our F list was FCAMBP, remember here? Then we can, starting from P, we can find all the frequent item sets containing P from the P subtree. Okay, we get all the records, all the transactions containing P, and that forms a P subtree, or a projection of the entire database on P. And then we can, the other partition may be all the item sets having M, but not P. And we can construct this set of, find this set of transactions from the entire database that can support us to mine those frequent items containing M but not P, because P was mined earlier from the P projected database. Similarly, we follow this order, and eventually we're going to mine the C items that containing frequent items that containing C but not A, B, and P, because all of those were mined from other subsets, right? So this is the idea. From the list item, we need to start from the list item. This should be clear why we need to do that. It's the only logical way that we can do this. But once we see how we do this projection, you will see that we, starting from the list of frequent items, following this reversed order makes sense.